Okay, probably good for us to continue at this point. And yeah, as you hopefully recall, right before we took our break, they mentioned that there would be these poll questions up. And there are two of them, both related to things where we are doing some kind of combination of values and bringing together some different data types to kind of just remind you of the compatibility of different data types. So the first question here, select the output you expect when you execute the following statement, which is print station ID plus station ln. I don't remember off the top of my head what the values are, but the station ID was a numerical value, right? It was a data type int, if I remember correctly. And station ln was a floating point number. So even though an integer number is considered a different data type in Python than a floating point number, it's a number plus another number. And when you add two numbers together, that's not a problem to do. So what it means is we would not expect to see a type error or a syntax error here. But instead, I think the correct answer would be this second option. Let's see what people said themselves. So a little bit of distribution of what we would see in the responses here. But yeah, what we basically would be doing here, if we jump back to our notebook for just a second, when we combine our values together here, we had, I've got to go back up a little ways to find it, maybe more than a little ways up here. We defined this list with this information about the Kaivopuisto station. So we had our station ID, which is 132310, and our station ln, which is 2496. And when you add those together, you should get 132,334.96 because it's just 24.96 plus this number that's here. So 132,334.96 is what we would expect. And that is then, yes, the second option, which was the sort of majority choice there. There's no type error in this case because numerical values, whether they're whole or decimal values, can be combined together. What Python will do then automatically is convert the whole number into a decimal value and then add them together. But they're considered basically compatible data types. What was our other question? So then, what happens when you execute print station name plus station ID str? So station name was a data type str, string, right? Character string. Station ID str is also a character string value. So it seems that they might be compatible. What happens when you add them together is that you do not get a type error or a syntax error in this case. Let's have a look at what people said maybe before giving away the exciting conclusion. But yes, basically what we're seeing here is in fact the sort of correct response that got the majority of the votes here. So no problem for a type error because the data types are both compatible and you can add character strings together. It just concatenates them. So it takes the first one and starts with that and then adds the second one right after it. Excuse me, sorry about that. So they're totally fine to do that. Because we converted this number into a character string, then what happens is we get Helsinki Kaivopuisto 132310. So it's not necessarily a very nice looking output, but of course you could make this look a little bit nicer and we'll show you some examples of how to do that. But that's totally fine. When you have a plus with two character strings, it just takes the first one and adds the second one right after it. It's totally compatible in that way. If you did minus, for example, that would not work, but plus is totally fine for combining character strings. Any questions about that, or does that sort of make sense? Yeah, okay. I'm just trying to scroll my way down to where we left off. which was about combining text and numbers. So what we saw is like, we converted one character string or one number into a character string and then added them together. It's really common that you want to take something like a character string value and a number and put them together in Python and get nice output for that. So we have something here like station name and ID. And we can basically do what we just did, more or less, in our example. But let's make it look a little bit nicer. So our second polling question, we already did something like this, but we could make a variable here called station name and ID, which is probably pushing the limit of about as long of a variable name as you want to work with, but still okay. And we'll say it's station name plus, and we'll add some little formatting things in here. So we can add in a sort of colon and then a space. So this is also character string, so plus, not a problem to have that be station name's a character string. We're going to add a character string, and then plus, and then we'll do station ID STR. So we can combine it like this. I'll show you another little trick here. If you want to do this without having to make this station ID variable its own separate thing, you could also do this string function and just put station ID in there, because this will return a character string. So then you would have character string plus character string plus character string. And it doesn't matter that there's three, it will just add all three together. So we would run this and then print it out. Station, name, and ID. What we should get is our station name, colon, space, and then the station ID printed out. So we get Helsinki Kaivopuisto, colon, space, and then the number that we had there. So this kind of thing, combining numbers and text, is really common. This is one way you can do it. Maybe you're sensing a theme in today's lesson. There's also other possibilities for how you can do this. And that's what the last part of the Python lesson for today goes into, which is a little bit more about working with text and numbers. So we've seen that we can add together these character strings, but there's actually ways in which you can format things in Python several different ways. The one that we're going to introduce to you and recommend using is called F strings, or format strings. I think the F in that case is short for format. And it is sort of the most recent iteration of how to combine text and numbers, for example, in Python. There's an earlier thing called .format, and there's an even earlier one using this % operator. I think you'll be grateful that you don't have to do things with the % operator, because it was rather clumsy to use. But imagine a case here where we have a temperature value. It's a number with lots of decimal places. So we can just run this cell here to define a variable called temp. And then we're going to make a string of text to print out to the screen that looks nice, that includes our temperature value. So we can make a variable here called info text. And don't worry, there's examples of how to do this with the format and the % approach below, but I won't make you suffer through typing those in. But the way in which we indicate this as an F string is you put a lowercase f and then you put some things in quotation marks. This is going to treat the stuff inside the quotation marks as, yes, a string, but as a special kind of string. So that inside here we can type in string-like stuff like the temperature, and then we want to give our station name variable here. So here is where we're going to use these curly braces. So well, I don't know whether you know how to make the curly braces, but at least for me on the Mac, it's Option Shift, and then I do the parentheses. I have sort of finished keyboard layout, so hopefully that's somewhat similar. But if you're having trouble making curly brackets or curly braces, maybe just raise your hand and perhaps Kamyar can give some assistance. But what we're doing with the curly braces here is we're indicating something special inside our F string. And here we're going to give a variable value. In this case, we're going to say the temperature at station name So inside the curly braces, we have a variable value that's going to get substituted in to this place in our character string. And then we can say station, and then put here ID, and then we're going to put another one of these pairs of curly braces for our station ID. So the temperature at, and then we have here one variable that's going to get substituted in station, and then we're writing in parentheses ID, and here's another variable that's going to get substituted in station ID, is, here comes the fun stuff, temp colon 0.2F Celsius. And I would probably say degrees Celsius because I'm just picky. Okay, so maybe this part makes sense, that you can basically substitute in a variable here. And by making it an F string, you're identifying that, like, if you delete this F, it will print out something quite different. Maybe I'll demonstrate that in just a second, but let's show how it works properly first. But we're indicating here we're going to substitute in a value for station name, substitute in a value for station ID, and we're going to do the same thing for temp, but what we're adding here is a formatting string. So what this is going to do is it's going to display the value of temp, but as a decimal value with 2 values after the decimal point. That's what the 0.2 is, and the F is going to indicate you want to show it as a floating point number. You could also show it using scientific notation if you wanted to, but this is just a kind of way to say how I want to format the number here. Let's run it and see what kind of output we get. So we run that cell, and if we print our info text, that's the way we can actually see what we just did. You get the temperature at Helsinki Kaivopuisto, which is what we had for station name. ID, and then there's our station ID, is 18.57 degrees Celsius. I do not want to install this update. Go away. So we had up here 18.567 blah, blah, blah. So what you can see is it's rounded our value to 2 decimal places. That's also a pretty common thing to want to do with Python output, especially like if you divide 2 numbers and you get something with 16 values after the decimal place. It's really ugly to work with numbers like that, so this formatting allows us to say, like, well, I don't really care about the other 14 decimal places, just give me the first 2. And then we can get nice looking output like that. I mentioned that if you take away the F, you're going to get something that looks different. If you get rid of the F here, what it's going to do is just take this entire thing and treat it just like a single character string. So if I just run these 2 cells once again, now you can see that you don't get this substitution happening here, but you actually get the exact string you typed in. So the F there is really important to indicate that what you want to do is substitute in a variable value, not just print out this exact string as it's typed in. So if you're trying to use these kind of F strings and you're like, why doesn't it work? Why am I getting this? It's probably because you're actually missing the F part that indicates that this is in fact a kind of special type of character string. Does that make sense to some degree? Again, you'll get to practice with this in the exercise. And I would say that, like, as you start processing more and more data, this can be a really useful way to, like, print out values and quickly just see for yourself, does the data I'm dealing with, like, make sense? And being able to limit the number of decimal places and things like that can be quite handy. Again, I mentioned that you can format things differently. If you change this F to an E, that will indicate you want to use scientific notation instead. So if we run this and print it out, now you get 2 decimal places, but now it's written in scientific notation. There are a few other things I can't remember off the top of my head, some of the other formatting options that you have are available for you, but most often you want to use the dot some number F to indicate you want floating point numbers. There's more of an explanation of this on the course page and here in the notebook. So there's a couple examples here saying how you can get scientific notation or convert things to percentages. Again, that can be a quick way to do things. And then there's also some examples of how to do exactly the same thing using the dot format and the older percent way. So, like, I guess just looking at this, probably you can tell it's a little bit less intuitive how to use this this style of formatting, but this is something that's kind of from earlier versions of Python. But there's more information here as well if you want to take a look, a couple links that might be useful. But I think that's basically the end of the Python part of the lesson. Now we're going to talk about some other things, like about version control and also about our exercise for this week. But before we go there, do you have any questions about the stuff we've learned in today's Python lesson? So maybe by show of hands, how many of you feel at least somewhat capable of working with Python lists? Okay. The somewhat part, of course, is subjective, but that's good. Everybody, I mean, if you feel at least capable, that means that you'll have the exercise where you can practice and find out. So that's good news. All right. If there's nothing else, what I'll do is jump back here to our to the course page. And we've gone through our basic elements of Python lesson. Again, just as a reminder there, if you want to go through and see all of the kind of things that we are supposed to be typed in during the lesson, you'll see all the output for the notebook on the course page. And so you can always go there. If you missed something during the lesson, you can go and have a look at the course page and see what we've gone through. But our focus for the rest of today's class, other than maybe going through the exercise at the end, our focus is going to be about version control and kind of what's the concept, what is this Git software about, and what is GitHub, and how do all these kind of pieces about version control fit together. And we can start with a hopefully not too familiar, but probably somewhat familiar example about looking, for instance, in someone's documents folder and finding, these string of files with fun names like untitled241.doc, untitled138 copy.docx. These kind of things are, of course, not things that you sort of maybe are proud of having on your own computer, but pretty common. Or for those of you who have started working on your master's thesis or have gotten feedback from thesis supervisors at any given stage, you celebrate finishing some document, you give it to your supervisor and get feedback, and then you make a revision 2.doc and revision 6.comments, revision 8, blah, blah, blah. You keep revising and revising and revising this document and making copies of it every time. But each one of those copies you make are related to the same original starting point document. So it would be really nice to not have them all be separate files, because then you don't necessarily know based on the name, unless you're consistent about naming them, which version order they're in. And that's part of the reason why we want to introduce the idea of version control here. So you can find, again, a bit more text about this on the course page if you're interested. But the basic idea for version control is perhaps exactly as the name would suggest. It's used to track changes to documents. And that can be tracking changes to a Word document, but more often than not, what we're using it for in courses like this is to track changes to our software or to our Jupyter Notebook documents. So when you have some version of a document like this and you maybe change something on the last line, you can see, for instance, here that the last line has been modified. And so what we're tracking with version control is what has changed between this version and that version. And so there's one line that's changed here. And then between this version and this version, there's 3 new lines here. So this is basically just an illustration of keeping track of just what has changed between versions. So we don't keep the whole revision 1 and revision 2, but just what's different between the two. And this is a bit like the track changes functionality in Microsoft Word, for example. But with track changes, you don't have necessarily a specific group of changes that you keep in the document, but it's typically only the most recent changes that are stored there. So, one of the kind of obvious reasons to avoid these kind of situations that are in the comics above, using version control is essentially a good motivation to avoid that. It's a way to keep track of the changes of some kind of document in an organized way. So rather than having to rename files and organize it yourself, the version control software takes care of keeping track of your changes. And especially when it comes to software where maybe you had a code version that was working, you did some things and you run it and now it doesn't work. With the version control option, you always have the possibility that you can go back and find the version that was working before and figure out what you changed and why something may have broken. So for programming, that's the kind of perhaps the biggest benefit, is you can always go back and find earlier versions of things you've been working on, and if you've accidentally deleted something or whatever, you have a chance to potentially restore it. So these version control systems, the software that you can use for doing this, there's a few of them that are out there, but Git is probably the most popular one. And so that's what we're using in the course for that reason, but also because it was developed by a rather famous Finn. So Linus Torvalds was the one who created Git, as well as creating the Linux operating system. And it's become pretty much the most widespread version control software that's out there. Now, with Git, we have files that are grouped together into a thing called a repository. That's basically just a collection of files that are associated in some place where you're keeping track of a set of the files. So oftentimes it's like a directory of files that you would have that are grouped together. And what happens with Git is you basically keep snapshots whenever you tell the software to save one. You keep a snapshot of what things looked like at the time when you saved your changes. So it's not quite automatic. It doesn't kind of regularly save what you're doing, but it relies on you saying when you want to save things. And there's a good reason for that, because sometimes you only want to save changes to certain files, and Git allows you to do that. It links up with GitHub, which perhaps maybe makes sense because the first half of GitHub is the word Git. But the hub part is basically meaning that that's a way to sort of bring a social element to the software that you manage in something like Git. So we're going to go through how to save changes to our files in Git in just a moment, but just to give you an idea for like what GitHub is all about. It is essentially running Git in the background, but it has this kind of social piece. So there's a kind of collaborative network. Often when people are working with software, they're not working alone, but they're working with other people. And as a result, there's a necessity that you have some way to kind of communicate about the code that you're working on. It's also supporting open source software and open science, because it's possible to basically share your software with millions of people through GitHub, which is a great thing to do in terms of open science. But it also provides some basic ways in which you can provide documentation about your software. So that can also be a very useful piece of why GitHub is a thing to use, is not only is your software there and available, but you can provide some description of how the software works, how to install it maybe, and some basic documentation, as well as providing things like issue tracking. So if somebody wants to use your software, they start using it and they find a problem, there's a place where they can report the problem or ask for help or suggest a change. Maybe they say like, oh, it would be great if you could also, support some other file format for reading your data. There's this issue tracker in GitHub that allows people to make note of things that either are problems or could be potential ways in which the software could be improved. So along with using Git comes a bit of vocabulary. So you'll hear the word repository or repo fairly often. This is just often abbreviated to repo, but that's the collection of files that's part of one project in Git, essentially. So with each one of the exercises, you make a copy of the exercise, and it's the exercise repository that you copy. So then you have your own copy of that repository. We'll learn about what a commit is in just a moment, but that's basically where you say, I want to save changes to my code. Revision or a version is a modification or a different, like every time you save a commit, you make a new version of the code, basically. Cloning is a way to copy the code from GitHub or from some other source to, for instance, your computer. And then pushing and pulling, these are things about, when you pull things, you're basically taking files off GitHub, and when you push them, you're saving things to GitHub. And then merging is something I really hope we don't have to deal with because it can be quite messy. But that's a little bit of kind of overview stuff about version control. And we can talk a little bit more about Git now specifically, because we have to set something up on your CSC Notebooks environment to be able to work with the exercises from this week forward. So we're going to go through a few different steps here about how to clone a repository from GitHub. We'll do this inside Jupyter Lab. So it's kind of like when we copy the exercise or the lesson materials. We'll talk about how to clone your own repository from using the Git plugin in Jupyter Lab, how to add changes and save them or commit them, and then how to push those changes to GitHub. So you save them locally in the cloud environment first, and then you have to push them to make them go to GitHub. Some of this stuff I think will make more sense as we start doing it. But we've talked a little bit about what the repository is already. So imagine, for instance, if you think about your exercise number 1, that's already on GitHub. So that could be, for instance, what we call a remote repository. It's on this website. And there's different things that we can do to be able to interact with that code. So cloning it is a sort of typical first step, which is basically just making a copy of what's on GitHub and putting it on either your local computer or on the CSC notebooks. But that's copying down the files there. Then you can modify things, and through a couple different steps, maybe you make some changes and then you want to save them to GitHub and you push the changes to GitHub. And we'll go through how these different things link together, but this little diagram might be useful to refer back to if you start getting confused about pushing and pulling and these things. But I think the best way to do this is to actually to do it kind of hands-on. We can also maybe just make note of the fact that when you're modifying files in Git, I've mentioned it's not automatically saving things as you work with your files. So you have your working directory where maybe you've copied your exercise number 1 to the CSC notebooks and you're inside that directory and you're making changes. The way in which you indicate that I would like to save some of my changes is to first add them to what's called the staging area. I think this is probably one of the kind of more abstract things about Git, but you don't always want to save every change you've made to all the files in your working directory. So if you've modified your notebook and your README file in there, but maybe you only want to save the changes to the notebook, you would do this add step and only add the notebook to what's called the staging area. That means it's ready to be, that set of changes is ready to be saved. You actually save the changes using this commit step. So that's going to then, typically you would say, add a specific file name, and then when you make the commit, you leave a message that says, okay, I want to save these changes, and I'm going to give some message to say what I actually did. So like it could be that you commit it, and your message that you type in is, finished problem 1. And then that actually then saves the notebook after you have finished problem number 1, or in the sort of state it was in after finishing problem number 1. Again, this will be good to look back at perhaps after we go through the hands-on part. But in order to do this, we've got to go back into Jupyter Lab. So hopefully you still have Jupyter Lab open from the CSC notebooks. If not, you can maybe relaunch it. And we have to go through a step here of making a personal access token on GitHub. This might seem a little bit weird, but we have to do this once, and once it's done, it's done. So don't worry about that too much. What this personal access token will allow you to do is basically allow your user in GitHub to do things from the CSC notebook. So like it basically allows you to kind of have the authentication to save files to your private exercise repositories in GitHub. So to do this, we're going to need to have the CSC notebooks open. I already have that open here, for example, but we also need to go to GitHub's webpage. And so I'm going to open a new tab and go to github.com and then make it big so we can see. Probably I've got a bunch of stuff here that you don't, but don't worry about that. I'll just show you the stuff that we actually need to use to be able to follow the instructions here. And I'm going to move this over. So to create your personal access token, again, you can do this now or you can do it later with the instructions on the course page, but you can go to your user, probably just has some like initials there if you haven't uploaded a picture. But if you click on your user and you scroll down a little ways, you'll find the settings. Not quite at the very bottom, but you'll find settings there. You can click on settings and that will open up your GitHub, I don't know, profile or something like that. And if you scroll all the way to the bottom of this, you'll find developer settings at the very bottom. So you go to settings and then scroll all the way down to developer settings on GitHub. Is everybody logged into their GitHub? Yeah, okay. Because if you're not, of course, you won't be able to do this. But once you go to developer settings, you'll see inside here, there's a section called personal access tokens. That's where we want to go. And if you click on that, we're going to use this tokens classic. I have not tried this fine-grained tokens yet, so let's just stick with the reliable thing, tokens classic. So I click on this and I can see I have my token that I've already created. You probably have nothing there. And what we're going to do is we're going to make a new token by clicking up here at the top for generate new token. And then again, generate new token classic, not the other one. So if you click on that, you may, if you're using two-factor authentication, if you know what that means, you may be asked to put in an authentication code. So I have to do that for me. But if you're not, then you probably just came right to this new personal access token page. And then you can put a note here. So I'm just going to call this, it's like the name for your token. I'm just going to call it Geo-Python 2023. Call it whatever you like. But this is just a name that's affiliated with this token. Then you can choose how long the token's valid for. So I would suggest, I think, going to custom. And then you can put in maybe, if you look on here, I would say at least put it to the end of the year, because basically it's going to be something you're going to use anytime you need to do anything with the course materials here, like your exercises, you're going to use this token. So perhaps it's safest just to put it to the end of this year for how long it's valid. After that, it will stop working, and you would need to create a new token if you want to go in and modify your files again. So you've got a name, you've got an expiration, and then I'm just going to quickly look back here to see what scopes we need. I think it's repo, admin repo hook, and delete repo. So this kind of tells what permissions this token has. So you can put repo, which gives full access to your private repository. So when you're using that token, you can do anything you would be able to do to your repository. I think it's admin repo hook, if I'm not mistaken. Just double check that one. Yep. So admin repo hook, and then delete repo. So those three things will more or less give you full permission to modify stuff inside your own Git repository. So you would be able to, in your exercise repository, do things like see the status of the commits and invite people to collaborate, for example, read and write things. But it's those three. So again, just to be clear, repo, admin, repo hook, and delete repo as the permissions. Then you scroll all the way to the bottom and you can click generate token. I'm going to close that. So what you'll see here is that there is now this kind of text string that's, I don't know how many characters long, but random characters. And you want to click on this little copy button here because you won't see this character string again. You can't recover it. These tokens are meant to be kind of disposable. So You can click on the button here and it should say copied when you click it with a little check mark. And why are you still pestering about software updates? I think at this point we need to go back to Jupyter Lab. Yeah. So at this stage, we can go back to Jupyter Lab. You've hopefully copied your token. I'll just click the copy thing one more time. And then you can go in Jupyter Lab to File, New, and then select Text File. We're going to put this token here, just copy paste it into the text file, just for the moment to be stored somewhere. Because again, once you close that page in GitHub, you'll never see that token text again. Not a big deal. If you need to make a new token, it's fine. You can just delete the old one and make a new one. They're totally disposable things. But I'm just putting this in here for safekeeping for the moment, because we're going to refer back to that when we go to configure our access to our repository for today and for the future lessons. So let me see if I can do this without having to jump back and forth between too many windows. So we've created our token, and now if I go back here to the file browser, so I'm back in Jupyter Lab in the file browser. I'm going to click on this base folder to take me back to the home directory, go into my work, and now what I want to do is File, New, and actually, nope, that's not the way to do it. I guess I'm going to right click here, or you can click the button up here to make a new folder. So if you're in the My Work folder, we have notebooks there, but let's make a new folder here called Exercises. As you might imagine, that's where our exercise files can go. So we have now our exercise directory available there. And what we want to do is we're going to copy our exercise number 1 folder. And in order to copy our exercise number 1, we've got to go back to GitHub for a second. And I think if you go to your, just to github.com for yourself, my guess is you would see your exercise number 1, or you would at least see, I don't actually know what you see because I've got a whole bunch of stuff in mine. But you should be able to find your exercise number 1 perhaps in here in recent activity. Or if not, you can go to where it says github.com and do /geo-python-2023. And then exercise-1. And then dash your GitHub username. So mine's just Dave Whip, like that. Hopefully that's big enough that you can see that. But it's just github.com/geopython2023 /exercise-1 your GitHub username. And if you type that in, it should take you to your personal copy of exercise number 1. Is there anybody who's not able to get to their exercise number 1 this way? Okay. Seems like we're okay. So what do we need to do? Well, at this point, we're going to need to get this location of this exercise. So you can click on the code button here and you'll see this little drop down that appears. And what we want is this address that appears here. And if you just look, it should be HTTPS. That's highlighted by default when you click the code button, and you can just click the little copy thing here. What we're doing is we're just copying the location of where to find that exercise repository so that we can use it in Jupyter Lab. So go back to our Jupyter Lab window, and you'll see, again, in the exercises folder, you can double click on that one, so that now you should be in My Work/exercises. And then at that point, you can click on this little Git tool. And when you click that, you can see there's the option to open the file browser, initialize a repository, or clone a repository. Everybody with that? Yeah? We're going to clone a repository. So you can click on that one, and it says, okay, enter the URL or URI of the Git repository, and that's where you can paste in this thing you have hopefully just copied from GitHub to find your exercise repository. If you typed in mine, I can tell you right now it's not going to work because you won't have permission to access my private GitHub repository. So when you try to clone it, it's going to tell you that the permission is not available. So you have to make sure that this is your GitHub username here at the end of the name of the repository here. So if we're set up with that, you can then click clone, and it says cloning, and it says, wait, I need information here, because it should automatically recognize that in order to clone this, it actually needs your personal access token, because it's a private repository. Now, I've probably done something dumb here, because now I have this place where I can type in my name, but I don't actually have my personal access token. It's back here. So we should have copied that first, because we need to have this copied in order for this to work. But I think this is going to be kind of annoying, because when you type clone a repository, it also wants you to paste in the name of the repository you're cloning. So I'm pasting in the name of the repository, and I'm just going to type this nasty thing in. If you're smarter than me and you can figure out a way to do this without having to go in this order, please do. But I'm just going to paste in the name of my repository, hit clone, and I'm going to type in my GitHub username, and then get to work typing in this thing in the background here. Again, you should type in whatever your token is. I'm sure this is going to go perfectly the first time. Okay, at least I got lucky and typed in my personal access token the right way the first time. And then it told me that it's successfully cloned, and what I can see now is in my exercises directory, I have this exercise folder, exercise1-davewhip, because that's my GitHub username. I think it's worthwhile to make sure everybody gets to this stage with the personal access token and copying and stuff like that. So why don't we take a minute and you can work on this, and then we'll check in and see if anybody's still having trouble getting to this step, because you're going to need to do this for each one of the exercises. Not this make the token stuff, but you've got to have this working with the token in order to work with the exercises in the coming weeks. So yeah. How about this? Who's having trouble with this process? Is there anybody who's like stuck or not able to get this to work? Yeah, okay, we got at least one. So maybe Kamyar can give you a hand with that. Are there others? Okay. So yeah, let's take a minute here and get everybody sorted out. And again, this is something we should have to do once. So hopefully after that, we're all set. I think we are in okay shape to perhaps continue from here to see a few other things. We want to make sure we have time to look at the exercise. That would be a good thing. So don't panic if not everything's working perfectly at the moment, because you can always find the instructions on the course page about how to continue. But hopefully what you would see is that you have this exercise 1 with your username directory there, and you can double click on that, and probably you have a notebook in here. I don't, because I haven't done my homework, but I have my README file in here. And so let's go through the process of making a change to a file, to adding that change to the list of files that we want to save, committing the change, and then pushing the changes we've made to GitHub. This is the way in which we're going to interact with GitHub in the course, is using this little plugin to the Jupyter notebook. So there won't be like dragging and dropping files like we did in the first week. We didn't want to go through like all of this in week 1 to overwhelm you even further. So anyway, you've now cloned the repository. You have the copy there, and you can see, for instance, some basic things about it. So if we look in our Git tool here inside our directory, so again, make sure you're inside your exercise directory in the file browser. But if you go there, you can see some information here. For instance, like here's the name of the repository we're working in, the current branch. We haven't talked about branches, but don't worry about that. Main is what it should say here. And we can see that there's no untracked files, there's no changed files, and there's nothing staged to be saved. Basically, we haven't done anything, so there's nothing to do. Now, if we go back to the file browser and open up the README file, you can see there's some information in here that's basically maybe kind of ugly looking in its format, but this is the description of what to do for exercise number 1. And if you scroll down to the bottom of it, you could maybe go here and add something that says Python is, and you can put in whatever word you want to describe Python with. I'll say Python is fun. But of course, you can use your current kind of perception of Python to express yourself however you like. So let's add something here and then save this. So I'm just going to save the file. It's now saved on the CSC notebooks locally as a change that I've added Python is fun to the end of the file. If I go back to my Git tool now, I can see that there's this readme.md in the list of change files. Don't worry about the checkpoint thing here. That's not a, we can ignore that for right now. But you can see the readme file has changed. And if we want to save our change, the first thing we need to do is say which files do we want to save the changes to, and if the readme.md file is the one we want to save, you can click the plus button next to this, which indicates that we want to save changes to the readme file in GitHub. And you should see when you click the plus that it goes into this list of staged files now. So these are the ones that are going to be saved the next time we kind of do this snapshot with GitHub. In order to actually save the changes in the history of GitHub, in the sort of history of our Git repository, we have to type in a message here and then make this commit. So you could say, added comment about Python or something like that. Some kind of informative message. This is just a silly thing that we're doing right now, but like for you, if you're working on an exercise, it might be like fixed problem with problem number 1 or completed problem number 1 or something like that. Something that's actually meaningful so that when you go looking back, like let's say you break your code later, it's helpful to have these useful messages to know like where do I want to go back to when looking for places when the code might have worked in the past. So I could say added comment about Python to README or whatever. Doesn't matter if I put that there because the README file is the one that's being changed. Then I can click commit, and you should be prompted for this. First time you click this, it's going to ask you who is committing, and so you can put in your name and your email address. The idea with this is that whenever you make a change in Git, it will track who was the user that made the change, and it also provides their name and their email address with the idea that for collaborative projects, you might want to send that person an email and say, hey, what did you do? You broke the project code or whatever. But here, it just needs to know like who is actually making the changes, who's saving this. So I click OK. It says committing changes and then committed changes. Now, if we went back to GitHub at this point, nothing has changed on GitHub. We've only made changes locally on this cloud computer in the CSC Notebooks platform. So just to demonstrate that, here we are on GitHub in my exercise number 1 repository. And if I refresh this, I look at my README file, which is the first file that's visible here, scroll all the way to the bottom. There's no comment about Python here. We've only made changes on the CSC notebooks at this point. By committing our changes, we have now saved them. So what you would see is that there's no longer any files listed here as changed or staged, but we haven't pushed anything to GitHub yet. In order to do that, there is a button up here, and you can see this nice little orange like notification thing show up. To push our changes to GitHub, you have to basically click the push button, which will push the changes from CSC notebooks to GitHub. When you do that, you get this lovely pop-up that says, type in your credentials again, which, as we saw already, is lots of fun to figure out how to do that efficiently. So in order to not have to do this every single time, there is a way that we can save our credentials. This time I'm going to type them in once again because I just want to continue with this part of the lesson. But I think this time, luckily, I don't have to type in the name of the repository, so I can just copy my token again. So I push my changes. It says my username and my value for my personal access token. Hopefully you can type those two things in or paste them in. And then I click OK. It says pushing down here and successfully pushed. If your personal access token is working as it should, you should see that message that it was able to successfully push, which means it was able to save the files to GitHub. So by show of hands, how many people were able to push their changes? Yeah, okay, very good. It also means that now when we go to GitHub, if I refresh my view here for exercise number 1, I now see there's this Dave Whip thing here that wasn't there before. And there's the commit message I said, added comment about Python to README. And if I scroll down to the bottom of the README file, I now see Python is fun down there. Or Python is whatever you typed. So we've gone through the full thing now. We've copied things off of GitHub onto the CSC notebooks. We've made some changes and saved them on the CSC notebooks locally, and then pushed the changes up to GitHub. One thing, if you're working on projects where there's maybe more than one person who have access to write the code, is it's a good idea to always click this Pull Latest Changes button first. Okay, it's going to ask for my credentials. I don't want to type that in right now, but to pull the changes first and then push changes after that, because you always want to make sure that what the version of the code or the version of the repository that you're working in is the most up-to-date before you push changes. Otherwise, you might encounter these things that are called merge conflicts, and especially at your stage, I don't think you want to encounter merge conflicts. They're not fun even when you know what you're doing, but they're especially not fun when you don't yet really know how Git works. Essentially, it's a situation where if there are changes to files on the GitHub version of a repository and local changes to the same files on your computer and you try to push them together, Git says it most of the time won't know how to figure out which changes are the ones that are supposed to be saved. If both things have changed, it will create what's called a merge conflict and then say, you figure it out, which the you figure it out part can be kind of a pain. So I'm just going to scroll down through here to see where we're at in the lesson. I think we've been following the script pretty well. We've added our changes, we've committed. We pushed without pulling things first, so we probably should have pulled just to be safe. But yeah, this is worth noting that in this Git tool, if you look at our history, you can now see that there was this initial commit and then thinking about adding an assignment deadline. And then here's your commit message should also be shown in the history, so you can see the history of all the changes that have been made to this repository. Now, this is maybe a good place to tell Git how to remember our credentials. And this is a very handy thing to avoid having to type in your personal access token every time. In order to do this, we have to open a terminal window and copy some commands in there, but we do it once and then it should be all set after that, I hope. So let's go through that quickly so you can see how to set GitHub up so it stops asking for your credentials every time. I think you could also tick the little box to save my credentials temporarily, but I don't know how long it actually saves them for like that. So anyway, in the CSC notebooks, to do this, you have to go to File, New, and then this time we're going to go to Terminal. So you can click on that. You should see this little terminal window pop up with some kind of weird thing that looks slightly different than this, but you can see there's a blinking command prompt there. It's waiting for you to type something in. And what we're going to do is we're going to select this text here from the course page. So if you're not there, it's in this Meet Git lesson. If you don't want to do this right now, that's fine, but you can do it if you like. But I'm just going to copy that and paste it in here. So it says git config -- global credential.helper blah, blah, blah. That is saving this stuff here. And let's test this out here in our terminal window. So they just copied, pasted this off the course page, hit enter. It's now saved. And then according to the instructions here, we should go to our exercise directory. So we're going to type cd exercises /exercise1 and then whatever your GitHub username is. So paste that there. But yes, it should be your GitHub username, not mine. And actually, we need to go to my work /exercises /exercise1. And that should then, okay, why don't you like that? My work exercises exercise, it's misspelled. Exercise 1. Yeah. So if you type this, cd my work /exercises /exercise1 - your GitHub username, you can type ls to see the files that are there, and you'll see there's a README file here. And it should be that if you type in git space pull, this is the kind of manual way to do Git stuff, that it will ask you for your username. I don't think it's supposed to ask us for a username at this point. Why? No, actually, yeah, it is going to ask us for our username, and that's fine. So for this, then, we want to type in your GitHub username. Don't open that. Type in your GitHub username, and then the password here should be your personal access token. So I'm just going to go back and copy my personal access token one more time. Paste it. You won't see any output when you hit the paste, but it says now already up to date. And it should be the case that now when I try to pull things using this Git plugin with the button over here, it should successfully be able to pull. So the idea here is that we're going to create a place called .git credentials where we're going to save our personal access token inside of your own My Work directory. And that will allow you then to not have to type in your personal access token in order to access things on Git. How many of you were able to get that to work? Nobody. 1, 2, okay. So finally, something that didn't work. Okay, so let me clear this out, and we'll start over one more time, because this is going to save you a lot of hassle if you don't have to type this personal access token in every time. So we were in this when you opened up the terminal. In fact, let's do it like this. Let's go clean slate, close the terminal window. You're still in Jupyter Notebook. We'll go File, New, and then go to Terminal. I guess everybody was able to get that far, right? Then you open up this kind of foreign environment of interacting with the computer with the keyboard and commands that are supposed to be typed in here. And the first thing for this is we need to type in this command here, and maybe I'll just try to leave it on the screen for a moment here. I'm going to copy it from the course page, but it's git config space -- global, and then credential.helper space, watch out for this quotation mark here, and then in quotation marks you have store -- file, and then this thing here. It's easiest if you just copy paste this from the course page, but if you have to type it in, you can. Now, I don't know whether this is going to blow away my old one or not, but I don't care. I'll just do it again. Is everybody able to run that part? Yes. Okay. Then the next thing you're supposed to do is change directories into the directory where you have your exercise. So this is cd space my-work /exercises. And if you used a capital E in exercises, that might be one thing that's important. It's probably also case sensitive here that this should be a capital E, but I used a lowercase e for my exercises. And then it should be exercise -1 - your GitHub username. I'll just hide this thing for the moment so you can see more easily there. Now, when you hit enter here, you should see that this now changes, that there's this other stuff in blue before the $sign. And if you type ls and hit enter, you should see at least the README file. And if you've done your homework, you should have also your exercise 1 notebook file in there. Is everybody able to do that? No. Okay, how many people are able to do this? Okay. So for those who are not, maybe we'll put your hands up and we can kind of give a quick, okay, there's quite a few. So, okay, let's take a minute to get everybody sorted out. Okay, I think we've got most people in a functional state. If you're still having trouble, we may have some time, maybe, at the end. I think we're running out of time here, but for those of you who were able to change into the directory and just want to check that everything is working properly, once you're in there, you type ls and you see at least the README file, maybe the README file and your notebook from week 1. You can type git pull, which will try to copy the files down from GitHub. And if you hit enter, if you've not typed in yet your GitHub username and personal access token here, this is where you're going to be asked for those two things, and you shouldn't be asked for that again. Like whether you do this, I mean, if you want to go and do all the Git stuff in the terminal, you can. But if you're using this GitHub or this Git plugin over here on the left, it should be the case that you also won't be asked for your token again there either. But you will have to type your GitHub username, and when it asks for your password, it's actually the personal access token, not a password. So at least, I think I deleted my old output so you can't see when it asked for my token the first time, but I think it did actually ask for password, but it's actually the personal access token. Little bit confusing, so sorry for that. In the interest of time, we have like 10 minutes, and I think we have more than 10 minutes of stuff to go through, and I'm not going to keep you past 12. So maybe if you're still having Git issues, this is a great opportunity to go to the exercise help session or to ask some questions on Discord after class. We're happy to continue to help with that. And maybe if there's any time, we can stick around and help with any other problems you're still having. So I think that's kind of the end of our intro to Git. Just to note on the course page, if you do want to use or know something about how to use Git from the terminal, there's instructions there for how to do that. That's probably for more advanced people, but yeah. Yeah, when you paste, it doesn't show any output. Yeah, so don't worry. When you put the password prompt in, it doesn't show anything on the screen, but it does actually paste the password in there. It's a little bit confusing. I think we kind of went through how to do this GitHub Classroom thing very briefly last time, but basically for each one of our assignments, in order to make your copy of the assignment that you can work on, you'll see when you go to the exercise page, this thing like start your assignment, you click on this link, and that's how it creates the copy of your exercise. There's a little bit more information on the course page about that. Yeah.
I don't know if I missed about where can we see our pairs? Just are we supposed to work in pairs?
Yeah, so we're going to post in Discord about the pairs thing for the exercises because we still have some people who are late registering, so we're making the final list of people, but we'll inform you about the pairs thing. I'm going to get into the exercise here in just a second, so I know that we're kind of running into your time. I did want to note that there is a good coding practice thing about describing your code here. It's basically about how to use comments and things like markdown cells. We'll do some of this stuff in the exercise for this week. But for example, we'll talk about these things like line comments, which is basically a way to add in some text describing what your code does, but it doesn't actually do anything. Like this comment is just ignored by Python, but it can help describe what your code is doing. So that's a handy thing. So have a look at the good coding practice if you have time, because there's some useful tips in there about how to use different kinds of comments. But yes, exercise number 2 is here. And we've got a couple minutes to take a quick look at it. A few things that are important to note about this exercise. Of course, it's due in 1 week from today at the start of class. That's nothing unusual. But we are working in pairs on this exercise. So what that means is we will post in Discord, most probably tomorrow, a list of all the pairs so that you know who you're working with. But the idea for this exercise and for the exercise for the next few weeks is that we're going to put you together so that one person is basically the driver and one person is the navigator. And sorry, the basic idea behind this is actually following a kind of coding practice called pair programming, where when two people sit together looking at the screen and one person's typing things in, the other person's looking over their shoulder, the person who's just watching the person type things in not only follows along with the person who's at the keyboard is doing, but catches a lot of these little mistakes like, oh, you're missing a parentheses here, or you're missing a quotation mark. All these little kind of things that trip you up and waste a bunch of your time often get caught by that other person who's just following along with what you're doing. But they're also kind of thinking, well, the person is typing and may catch little things about like, oh, maybe you could do this instead. So by working together, it sort of should improve your efficiency in working on the exercises. But you need to know basically who is the driver and who's the navigator for each week, because essentially there'll be one person in the pair who's the driver. We're only going to grade the driver's exercise that week, and then you'll alternate weeks who's the driver and who's the navigator. So we find, at least for the first few weeks of the course, this is a nice way to kind of help ease into working on the exercises. And about week 5 or so, there's often people who start saying like, I'd rather work on my own, and we can discuss that when we get there. But you'll find more information about the kind of idea and philosophy behind why we pair people up on the course webpage. Anyway, the main thing about that is you'll see something in Discord listing the pairs, and we'll help you out with that. When you make your copy of the exercise, you have the administrator privileges, so you can invite your partner to also have access to your repository. So you can both see what's going on. For the exercise itself, there's There's 3 problems. They're all in one single notebook. So when you make your copy of the exercise this week, there'll be a README file, but there will also be this notebook in there. And you'll see inside the notebook some things that look like this, where it says your code here, raised not implemented error. You should delete that and type in your solution there. We use a sort of automated grading system that puts this in there to help us see whether or not you've done the problem. And you would have to then delete this and type in your answer to the problem. You'll see, I think, pretty quickly that if you don't do that, this raised not implemented error will basically give an error message every time you run the cell in the notebook. So you'll have to delete that in order for the code to work. There are also some other cells in there called markdown cells. These are ones that can be used just for typing in documentation. And instead of having this not implemented error, it just says your answer here. So you just delete the your answer here and type in your actual answer there. But yeah, this notebook is going to be a little bit more structured, so please just have a look at the stuff at the beginning of the exercise just to read through. Like, there's some suggestions like don't change the file names, don't copy and paste the cells in the notebook. So you can add new cells, but copy and pasting the cells breaks our automated grader. So that means somebody then has to go back into your exercise and fix things manually, which is just a bit kind of defeating the purpose of having an automated grading system if we have to go back and manually fix notebooks. And there's also like the cell types. If you're inside Jupyter Lab, for example, there's like this cell here that's labeled as code, and if you change it to something other than code, it will also cause the autograder to kind of not function properly. So there's some tips on there. There's also something here about this, we've added new for this year, this kind of AI tool usage agreement. So we're asking you to just acknowledge that you have read the guidelines for the use of things like ChatGPT and agree that you are following the guidelines in the exercise. There is no opportunity this week to use ChatGPT for or similar tools in the exercise, so please don't do that. In later exercises, when things get a little bit more complicated and maybe more interesting, we're working on ways that we could let you try and test out some of these AI tools to just see what they can do. But there's nothing for that for this week, so please refrain from using ChatGPT. Otherwise, we've got 3 problems. One is about making some lists and changing it, and also getting some practice using Git. So you've got some table data here that you'll put into a couple Python lists, and then you've got some extra things to add to the table or to your lists. You'll notice here, this is the notebook for the exercise, that there's this kind of, here's where you can delete things and put in your code, where it says your code here, blah, blah, blah. But there's also these tests in here. These are, you won't be able to edit these cells, but this will just let you know whether or not you're on the right track. So it checks to see, like, is the length of station names equal to 5? So that tells you whether your list is the right size. Is the length of station start years equal to 5? So there's these kind of tests that are built in to help you see if you run these cells and you don't get any error messages, it means that you're most likely getting the correct answer for that part of the problem. So you mess with lists a little bit, and then there's a place here where you can describe like how, what kind of problems you had, or if there's any, well, I guess actually for this question, it's kind of like, do you see any issue with what we've done in the exercise? Leave me alone. So, and then there's an optional problem here if you want to do some Googling and figure out another thing we didn't introduce in class. There's an extra thing you can do there. Then we've got something about monthly average temperatures. This is just to practice a little bit with like reading, again, more information from a set of lists and printing out things. So this should be kind of that it reads the month and prints out the average temperature for that month. And then there's some description of how you'll be assessed. And then there's a practice using Markdown where you can basically put in some answers to how things went this week and also add a picture of an animal that you like. So this is just a practice showing you what you can do with Markdown. Okay, we probably have like 15 seconds left. We've thrown a lot of information at you, but if you have any questions or anything like that, Kamyar and I will be here for a moment. You can come down and ask us. Otherwise, good luck and see you in the exercise sessions on Thursday and Friday.